Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. This is a part 2 of the same problem. Body is going from V0 and it flies like that, and this is parabola and this is incline, and it meets here. And last time we solved it standard way, horizontal x, vertical y, we directed it down, g became positive, this is straight line, this is parabola, they meet here, and this is the point where they meet, and we determine this distance. And this was length and this was height. And everything was fine, but now I want to ask you to solve the same problem in different coordinate system. And specifically what I mean, if this is the same incline, I want to put x this way. It's my right. Not horizontal, but under the angle. And y should go that way. Right? And let's start at this point where I'm starting this incline. So this incline and x would be straight along the incline. Right? And the body will fly that way. And this would be x and this would be y. And here are the trickery. Right now, this movement will not be at all constant speed, because we have g, and if this is angle alpha, then g will have projection, and if this is alpha, this is alpha. In projection, g in this direction would be g opposite sine alpha. So g would be directed here, and it would be positive because it's this way. On another hand, this projection along this vertical line, if this is g sine alpha, this would be g cosine alpha. And it will be everywhere negative, g cosine alpha. And that's basically the difference. But this would be straight the distance here. So, x, it would be acceleration. And we will have v0. v0 is horizontal. So, projection on x, v0, vx would be v0. And if this angle is alpha, then it would be cosine alpha. And Vy is projection in this direction, it would be V0 sine alpha. So it would be very, very different, because this sine and cosine alpha would be a little bit trickery, and this exercise will show you different method in this system of coordinate when we have not superposition of constant speed and acceleration, but we have superposition of two acceleration, movement with a constant acceleration along this and along this. And we can say that gx along this is g sine alpha, and gy equals minus g cosine alpha. Let me take another piece of chalk. And so you notice that this would be along x-axis, it would be cosine, but this would be sine. This would be sine, but it would be cosine along y-axis, and the sine too. So it may look a little bit more complicated, but not really. So along x-axis we will have x equal initial speed, which is v0 cosine alpha, multiply t plus at squared. A is g sine alpha t squared over 2. And along y, we will have initial speed is v0 sine alpha t, acceleration minus g, put 2, I'm infringing here, 2 is here, minus g cosine alpha multiplied by t squared over 2. And those are two movements. And of course, all I'm interested when this will intersect. So I'm interested where y equals 0. So I can plug y equals 0 here, and I will have, if y equals 0, x becomes d, or x becomes 0 too. First solution would be time equals 0, t 0, everything is 0, we in this point. And second solution would be when x becomes d, y becomes 0, and time would be the time of our flight. So basically, this is the solution. Another way of solving this is to recall that in this motion, this determines only how far we will go, but the time up determines by this motion. The time up. The time up determines by this motion, and the time down also will determine by this motion. So, for example, we can solve it in many different ways. For example, we can find here time straight from this equation. When y equals 0, we can say that 0 equals v sine alpha t minus gt squared over 2. Oh, I forgot already cosine. I'm rewriting this without any changes, and I'm rushing. And this is not good, not recommended, because mistakes will crop. I will move it to one side, so t squared would be positive, multiplied by 2, and I will have g cosine t squared minus 2v0 sine alpha t equals 0, because I multiplied by 2 and moved it to another side, so in front of t squared I have positive thing. I factor t out, I have g cosine alpha multiplied by t, minus 2v0 sine alpha equals 0. First solution, t equals 0. This is when we're here, because multiplication of two things is 0 when either this one or this one. And second solution is this bracket is 0. So I write g cosine t, well, let's put it t smaller case, minus 2v0 sine alpha equals 0, this thing. Then I move it to other side, so g cosine alpha multiplied by t equal 2v0 sine alpha. And then I have time equal this thing, 2v0 sine alpha divided over g cosine alpha. And it's pretty straightforward. We could receive this in different way. Because if we will look on this movement, the formula that we could use is the formula for the speed. V equal V0 plus AT, right? And if we say that the maximum point, the maximum height is where speed equals 0, and initial speed is v0 cosine, and acceleration g cosine. So we exactly have this. We have to multiply by 2. It's the same standard formula that we have about acceleration. Movement with a constant acceleration, that's the time equal initial speed divided over a. It's when we start and go to the top point. And here we multiply by 2, and we have not v0, but along v0 sine alpha, and on the bottom is acceleration, and acceleration g cosine alpha. And science take care about all of this, but basically this is our time up. And time up determines the time when we go up in this direction and then back. That's why it's 2. And so now all we have to do is to plug this number into x. I wipe it out, I leave this, and I say that my x is actually becomes d, because when we come back to y equals 0, this would be this point, and d would be v0 cosine alpha multiplied by t, 2v0 sine alpha divided over g cosine alpha, right, plus this, and this would be g sine alpha divided over 2, and now I have to t squared, so I put t squared and it would become 4, because v0 squared sine squared divided over g squared cosine squared. So it looks like ugly, but it's not that much. So I continue, or I can write like, not like this, but continue with this, d equals. So cosine and cosine is gone, 2 is 2, but 2v0 squared, v0 over v0, sine alpha divided over g, and this is this guy. Now let's go with this second one, plus 4 and 2 are gone, becomes 2. G and g squared has gone, become g. Cosine squared stays, and sine cubical. This is it. So continue. D equal common denominator g cosine square. And remember, I want to receive this number, so we're already happy because I have this common denominator, so it looks quite good. So here I have to multiply cosine squared, so I write 2 v0 sine alpha as is, and multiply by cosine square alpha. And then I put here, oh, I forgot v0 too. v0 squared, simply forgot. Plus 2v0 squared sine cube alpha. And I don't have room, so I have to sacrifice something on top. For example, I sacrifice this line and try to fit it here. So I have d equal common denominator g cosine square alpha. Here, let me factor out what I have. I have dv0 sine alpha everywhere. So I factor this out. dv0 sine alpha. And from this one I have cosine. And from this I have sine squared. Cosine left, those two out. 2v0 squared sine left, but this is 1. And if this is 1, this becomes this, so I didn't lie to you. So basically, what I try to say, I came to the same result, but I used different coordinate system. I directed it under the angle to g. So in both axes, there was acceleration. On one x, it was g sine alpha, and another minus g cosine alpha. And the speed was a little bit different. And so, I received the same result. Maybe the first solution was simpler, but this solution is more physical because it brings us to the point that moving in this direction defines us time. And it also defines us this height. And when we know the time, we simply plug this time, and it so happens that during this time it covers the distance d. And so basically, this is more physical, I think. It's more physical meaning. But the bottom line here also, the moral of the story is that you can choose y the way you want. You can direct it this way, that way, this way, that way. It's all would be reflected in the signs. And also it turns out that you can put it this direction or you can put this direction. It's whatever is better for your physical problem. And of course you have to know, be very fluent with those b0 cosine, how to find projection from the vector, how to find sine and cosine and tangent from triangle. And for that purpose I prepared two playlists. One is vectors, another is trigonometry, and I will put more in trigonometry shortly when I have time. But for the time being, that's always this problem. I may have one other installation with interesting question about it. But otherwise, if you liked it, like. If you want to see more, subscribe. If you want to be notified, click bell after you subscribe. And of course, if you have questions, you're welcome to ask.